Hello, I'm Jack from SetonixSynth, and this is our new multifunctional voltage processing hub, Laka. Laka is essentially a tricked-out control voltage processor in the style of old surge and buchla type modules. Each channel is capable of inverting and adding voltage offset to its input. A, B, C, and D channels all operate the same. When the module is entirely unpatched, there's a 5-volt offset normalized to the input of channel A right here, which in turn is normalized to channel B, channel C, and channel D. Patching into any of these will break the normalization at various points and route them to channels further down the line, but with nothing unpatched, you have a 5-volt input here, which you may use in combination with the fader to produce a -5 to +5 volt offset, or if you change the offset knob, which is itself set from -5 to +5 volts, you can change the window from +10 volts to 0 volts, as you can see, or anything in the middle. Likewise, if you only want negative voltage for some reason, you can go from 0 to 10 volts. It's very nice. And likewise, every channel can operate independently in this regard. At any time, also, regardless of position, the 0 switches down below, which correspond to A, B, C, and D, may be engaged, and this will essentially make the channel act as though the fader is perfectly in the middle. So the incoming voltage from the CV processor is zeroed out, but the offset remains functional. Down below, the submix outputs represent combinations of the indicated channels, while the sequential output here selects channel A, B, C, or D in order, using either the clock input or the manual button, and you can select the number of steps. 2 steps will only go between A and B. 3 steps will go to A, B, and C only, and 4 steps will allow you to manually or with a clock cycle through all 4 of the raw outputs, regardless of what they are. So in this mode, Laka is capable of acting essentially as a 4-step sequencer. It can do quite a bit more, but for instance, that is what would happen based on the selected levels of each of the channels. The same principles apply when processing an incoming CV. As the channel fader moves further from the center, the amplitude increases in either an inverted or non-inverted fashion. Each of the 4 channels is the same in this regard. So here we have the output from our cycling Bafacco Rampage, very good module. And as you can see, we're able to use channel A to increase the amplitude centered around 5 volts. Or sorry, centered around 0 volts. And when I mute it, as you can see, the channel is zeroed out. And the offset allows us to add or subtract a voltage. So when I switch the channel back on, as you can see, that offset will be applied, and we can essentially change the scope of the voltage, which is very nice. So if I want to, for example, change this unipolar signal to a bipolar signal, all I have to do is, because it's 0 to 10 volts, switch it all the way to -5 volts using the offset, and I have a nice bipolar signal. Now, because our normalization goes from left to right, anything patched into channel A will by default go to channel B as well. So when I switch it on, as you can see, it is also receiving input from the Bafacco Rampage, although I'm able to independently do anything I want. Likewise, further down the line, all of these will act on this signal. If I were to go ahead and add a second slope, for instance, as I will here, and patch it in, then channel B which I've just patched into, and all of the others will instead respond to that voltage, as you can see. Now, we're able to use this also to demonstrate the submix. So we have two different speeds of envelope going into the two different channels, and each of those individual processed outputs will be available on the A and B outputs here, but we also have a mixed output, which is outputting the sum. It's a little elaborate, but just a little. The sum of the two input voltages plus only the sum, or only the offset voltage added to the channel directly above it. Basically, just the only thing to remember is that this offset, the one for channel B, will not apply, but the one for channel A will, and that will allow you to change the scope of your overall voltage without interference from this other offset, which may be used to do stuff to channel B or to submix B and C, and we don't want it also working against us here. But essentially, the thing to remember is that each of these submix channels is really just a mix of plus or minus the input signals. So it can be used to really flip and combine and manipulate these two signals in many fun ways. Likewise, if we were to look at channel B and C right here, which are taking the same signal, so these are very loud output signals, 0 to 10 volts. But if we want, we can actually demonstrate the rail-to-rail behavior, which is, for especially quieter input signals, the sums can be used to amplify. So we are hitting, this is 12 volts right here, so we are hitting the very rail, or it can be used to, I don't know, phase cancel itself out if you want. I don't really think you have much reason to do that, but as you can see, the offset of this channel will still function. Sometimes it'll do that if there is clipping going on, but in the center it will just produce a phase canceled offset, or you can use it again to amplify or to take various strengths of smaller, weaker signals, or of course you can just zero one out, and that will allow you to get basically two offsetted versions of, for example, channel C. But we are getting rather heady. The thing to remember is, again, that, note again, if I patch into channel B and unmute it, it is essentially just a bipolar voltage processor, but we have all of these other cool options. So let's get into those. If I add more voltages, such as an LFO from the rot nest, as you can see, this will respond to that. And why don't we, for good measure, take something from Pamela's new workout as well. So we got a, let's see, we'll change this one to a random thing and patch our random thing into channel D here. Now, as you can see, Laka will be acting as a master mix, which is very handy. So here we are summing an LFO, 2 cycles, and a random voltage from the Pamela's new workout. And I'm able to, as you can see, I'm individually able to change the offset of each signal, but these will not affect the output much of the mix unless clipping is involved. Can't avoid that. But the offset of the master mix is D, the one above that. So it works the same way across the board, where these offsets control both the output, A, B, C, or D, as well as the corresponding submix output. Then, with all of these patched in and all of this stuff going, if you look at the sequential output, as we will, you will note A is selected, and we have the voltage coming from channel A. It's a little, wants to be triggered, but as you can see, with A selected, the sequential output will behave exactly as the channel A output. But what's really cool is you can just flip to channel B, and channel B will instead give you the output from our B channel, as you can see. C gives us a triangle wave LFO from Rotnest, and D gives us our Pam's New Workout output, which is a slow, smooth, random. Pretty cool. So here we have a patch that will, I hope, demonstrate some of Laka's capabilities as a control hub. So we have an envelope from our EG2 by Infinite Machinery right here, big up Jim, going to channel A of Laka, which is in turn being routed to channel B and C before the normalization is being broken by this rampage cycling envelope here. So as you can see, the LEDs are reflecting that, and what I essentially have set up right now is the individual outputs of Laka going really just two places right now. One to control the false CV of our auxiliary slope here, and the other controlling the voltage or the pitch of our oscillator a little bit. It can be nice to send an envelope along with a volt per octave signal, which I do have going because I do have a sequence going right now. But anyway, the main bread and butter of this patch, the main fun part, is that the sequential output here is routed to the input, the CV input of the Boing, which can deliver all sorts of really fun things that we're going to get into. So at the moment, it's only cycling between channel A and B, which are essentially the same thing. But as you can see, if I, for example, mess with the offset of channel B, we get a different behavior here, which we can, of course, leverage to, for example, turn step B into a fun kind of ducking thing for the Boing by manipulating the offset here. Basically, it means it's working in reverse during step B and working normally during step A, and I can control the amount of each as well. So I can control the positive direction and the negative direction with our two channel faders here, and this will also control the level going to the fall input here. And what you're seeing is just the A plus B plus C plus D output on the scope for fun. But anyway, if we, for example, get our third envelope, which is also being sent to the frequency input here into the mix, we can get even more varied behavior from our envelope. And nothing's also stopping us from adding our LFO here. So now we have, as you can hear, kind of a fun rhythmic melange of stuff, where as I change the envelope, we get all sorts of interesting modulations. So yeah, that's fun. And as you can see, you get a lot of inspiration from routing these things. Fun places. Playing with the Boing. Can also function as kind of a VC distortion phaser type thing. With the cutoff up, but down. So yeah, lots of fun, as you can see. And of course, we can patch more things in too, if we want, to the individual steps, like another LFO, for instance, or another slope. So yeah, you can see how the channels interact with each other at least a little bit more. You can definitely see how the sequential output controls our amplitude, but what's really nice about all these have your cake and eat it too outputs is that you get a lot of interesting feedback patching going. A lot of happy accidents. And that is the point with this module, is it presents, again, some pretty straightforward building blocks. You got your 4 attenuverting channels, offsets, straight up outputs, mix outputs, 0 switches, and a sequencer, but together you get a lot of fun stuff. So that is our hope with this module, and we hope you like it.